Hi, I'm Shawn. This is lifting moose. It's not. Should I keep talking? It's a little bit feedbacky. Okay, this is not Perl 6. There's a little bit of confusion about which room is which, but. All right. So this talk is about object-oriented programming. And one of the most important things about object-oriented programming is that you have behavior, which is like message passing or method calls. You have state, which is attributes or properties. And you have identity, which means that two objects with the same values for all their properties are still considered distinct objects. So every object-oriented programming language provides these. Otherwise, it wouldn't be object-oriented. But these are like the core OOP ideas, but then there's the details. And there's so many details, right? Like every programming language provides a unique take on OOP. Some languages provide inheritance via a class system, others provide it via prototyping. Some have final declarations, some have dynamic dispatch, some have generic methods. It's almost like you could pick any mix and match of features that you want, and there'd be a language there. Some languages even exist in the places where it doesn't quite make sense for that set of features. We don't talk about those very much. So we could even treat these languages as like points on a plane, where the position is determined by the set of OOP trade-offs that that language makes. So Perl's there, obviously. And then there's a bunch of other languages that are more or less different from other languages. By the way, don't take this chart too literally, it's just demonstrative. But I want to focus on this side. So I'm going to zoom in. Not very nice transition, sorry. But all these usual suspects are here. None of these languages actually provide the same kind of OOP. For example, Ruby is different from Perl in that it lets you subclass built-in types like string, array. In Python, you don't have to explicitly bless references. But otherwise, these are all kind of similar to Perl. They're all kind of dynamic. They're all more or less hash-based, weakly typed. So that's why they're in this quadrant together. But you might be thinking, this is Perl. There's more than one way to do it. The way I write OOP Perl is different from the way you write OOP Perl. And Ingy writes OOP Perl like nobody else. But Spiffy may not have worked out, but don't hate on Ingy. It was a good idea, just before its time. So you might be wondering, this talk is about Moose. Where is that on the chart? Moose, as it exists out of the box, is there. But there's something more going on. Moose is flexible and extensible in ways that these other systems are not. In fact, you can kind of extend Moose to be more like any of these other systems and anywhere in between. So I wouldn't say Moose is a point on this chart. It's more of a region. So based on the trade-offs you make, you can kind of find the right point in the region that you want. And that's what this talk is about. But I don't like that shape. It's kind of boring. It's not very moosey. So this is the region of Moose. So for example, there's inside-out Perl, which lets you store properties outside of the object. And MooseX inside-out is a module that lets you have that with Moose. So that's why inside-out objects is inside the region, because you can kind of move towards that point. And you can tweak that to be a point that's not quite on that same point. So for example, you might store properties by something other than object address. It's like some kind of application-specific identifier. So you can kind of move that point wherever you want in that space. And this is kind of the whole point of the talk. With Moose, you can move to any point in this region. So if I shed this point region metaphor a little bit, so you can kind of select exactly which features of OOP you want with Moose. And you don't even have to leave Perl. You can have it in Perl. And you can interoperate with other CPAN code. Because it's all mediated through method calls, right? So this is the true power of Moose. This is what keeps me writing Perl. It's not has. It's being able to select what OOP I want. And that's also why I don't use mouse or mo or moo. Some jerk. It was me. So mouse is a point on this chart. Moose is a region. That's why I like Moose. So Moose pulls this off by doing something so simple you probably wouldn't even expect that it could work. Moose itself is implemented using object-oriented techniques. So there are things like instances and classes and methods and attributes. These are all familiar. The other systems I mentioned, like standard Perl OOP, are implemented with things like hash tables and C functions and structs and pointers and glob assignments, which is not very extensible, right? We have OOP because it's very flexible and extensible. So in Moose, you can use any OOP technique to extend Moose. But those other systems are kind of a single artifact that you can't really tweak. So that's what you get with Moose. With those other systems, you get what you get, and you don't throw a fit. So because Moose is OOP, it's very familiar to extend it. You do it in two parts. First, you write the extension, and the extension can usually be a role, which makes it very clean. It's okay if you haven't seen roles before. The example will still be clear, I hope. So in this example, I looked at Moose's documentation or its code, depending on what I'm doing, and I figured out that new underscore object is the method that I care about. So in this case, I want to implement an extension that kind of complains about creating new objects. It's like a teenager or something. So I just override this new object method in my role, and then I can use it. So when I use this role, I get the standard Moose behavior plus this one tiny little change. So it's very easy to understand. And then the way we use this extension is we just tell Moose about it, this traits option. And that's it. Now this is robust and modular. Only the person class and its subclasses will get this behavior. You're not polluting other Moose using classes with this. So it's much better than alternatives like monkey patching. And behind the scenes, it's just saying, give me a subclass of whatever class Moose uses, and then add the reluctant role to it. Easy. It's just OOP. You subclass like a million classes, you can do this. And oftentimes, you don't even have to do it. There are literally millions of Moose extensions on CPAN. And each of these MooseX modules kind of fills in or expands the space that Moose can give you in the chart. So a lot of the times, you can just skip that first step and just start using extensions. So because Moose is OOP, there are no black boxes. In other words, the plumbing, which is like the internals, and the porcelain, which is like the user interface, are one and the same. There's nothing hidden beneath the surface. If you compare it with like standard Perl OOP, you can really only tweak a certain number of things, but then the rest of it's in C, it's off limits to you. So because Moose is this unified model, and it's a model you're already familiar with, you can use the porcelain that Moose provides to extend Moose. And by the way, our porcelain is terrific, as you know. Sometimes this leads to problems, though. Sometimes you get a plumbing problem where you're expecting a porcelain problem. And like the real world, this is a crappy situation to be in. I'm sorry. But this is kind of how Moose works. This is why we tell people you want stack traces, because the porcelain and the plumbing are one and the same. So if you just get that last line of code, you won't see what's going on. And yeah, I'm sorry. This is actually a real patent. It's a method for breathing fresh air in a room filled with toxic smoke. What do you think? Yeah. I don't know where I'm going with this. Let's talk about Moose. So what's this lifting business all about? It's great that you can use a Moose extension to add multi-methods or inside-out objects or anything, but your extensions to Moose don't really need to be about object-oriented programming. There are no limits. Your Moose extensions can be domain-specific or about your application. So imagine your application is a pink pill, right? It's sitting at the top of this stack, including Moose, Perl, operating system. What I'm proposing is that you lift Moose more into your application. I think that's not crazy, right? That's a little bit doable. So Moose becomes more of an active participant in how you structure your application. And really, the reason we're doing this is because you don't want to reinvent half of Moose poorly. So let's look at a concrete example of how you might do this. So the canonical examples kind of become web forms. So your classes have attributes, and perhaps you're writing a web form to populate those attributes. Here we have an email attribute with a form field. Thank you. So the first thing we can do is start looking at the core Moose options to see how we can make this better. The first easy one is required, right? Just inspect the attribute's required property, and if it's required, add that little asterisk to indicate that it's required. And then you can also hook into the form validation code to display an error if they forget to provide an email. And you can do this by inspecting the required attribute. And remember that Moose is implemented with OOP. So the way you do stuff is with method calls. So first thing you got to do is get the meta class. That's what arrow meta does. And you might be familiar with that whenever you use package underscore arrow meta arrow make immutable. That's also doing stuff in the meta object protocol. So it's, take a deep breath. It's not that complicated. It's just an object. You're just calling a method. And then this meta object represents your class. So classes have attributes, right? So one of the things you can do is pull out an attribute. And the attribute is an object. And that object knows about this email attribute. So it knows about things like required. So you can just ask it, is it required? And this will return yes or no based on whether that email attribute is required. And then you can put that little star and add to your form validation. So that's required. There's a bunch of other Moose options that you might integrate with your form. So for example, type constraint. Here we use an email type constraint. And that way, the form building code can inspect your type constraint and say, oh, it's email. I'll use input type equals email instead of input type equals text. That way the browser can do some of the validation and give you a nice keyboard on mobile. And of course you do, the standard email validation, which is hopefully just as simple as like a regex that matches dot at dot or something. But yeah, it's just inspecting this type constraint and then doing it. Moose has a documentation attribute. It lets you associate a string with that attribute. It isn't really used by the core code base at all, but you can use it here to display some help text on the form. So here we're just warning, or politely telling the user, we're not going to spam you, don't worry. That's not bad, but I think we can make it a little bit better. So for example, the email label is all lowercase. It's kind of ugly. It's kind of programmery. Strikes me as sloppy. And also, it would be nice if we had a little placeholder value that says this is email address. Grayed out text inside the form field. So we try to do that, and we say, oh, placeholder is email. But then Moose complains that placeholder is not an option you can use, which is perfectly reasonable, right? Placeholder is an HTML thing. It's not an object-oriented programming thing. And Moose is designed for OOP, not HTML. But, as I mentioned in this talk, Moose is extensible. So we can kind of make Moose more about HTML, which is what our application deals with. So we're enhancing Moose for our application. So how might we do this? Well, first we define an extension. Here's a perfectly complete extension to Moose. This role just adds an attribute to whatever class consumes it. And that's all you have to do. And then the second part is you just use that extension in your class. So here we're using the traits option to has, which basically lets you define extensions you want to use. And this lets us use that placeholder attribute that we created in the role. And that's all. So the placeholder attribute can use the full power of Moose. We gave it a string type constraint, so if we try to pass a hash reference there, it would throw an error at compile time. We can make the placeholder required, if that makes sense for our application. I don't think it would in the general case, but I don't know what you're doing. And you might be wondering, how do we get that string email out of this class, right? It's very similar to how we did it for required. The only difference is instead of asking is required, we ask for the placeholder value. It's just all OOP. It's very straightforward. So now we get a little placeholder in our input. Easy. Now the other problem I mentioned is the email is all lowercase in the label. So we'll fix that too. So we'll add this additional attribute to our field class, or our field role, sorry. Just named label. And then in our email attribute, we can use it. So that's a pretty good looking form field, I think. And this is the full attribute with all the options we specified. I don't think anything's too crazy there. It's all declarative, which is nice. You might consider how you might implement this without Moose. You might have like a subroutine that returns a complicated hash reference. But it's nice that it's all here in our attribute, because it means we don't have to duplicate code. For example, telling Moose that it's required and telling the HTML form builder that it's also required. There's no duplication there. It's all declarative. One small improvement we can clean up is probably getting rid of this. I think it's okay as it is. But luckily, because Moose has a vibrant MooseX ecosystem of extensions, we've built up in Moose a bunch of tools to make this even easier and more automatic. So instead, you can create a package with all your extensions in it. So this is similar to any MooseX module that you use. It automatically would apply the field role to all of our attributes. So, you have has email, has username, has birthday, all that stuff would just get that field attribute automatically. I'm sorry, field extension. So that's about as sweet as you could ask for, right? And of course, it's not limited to just generic HTML. Maybe our application does different things based on mobile or desktop or tablet. So whatever our application's needs are, we can model them inside our attribute. So, of course, we're not just limited to adding attributes to our attributes. We can extend Moose's concept of class, attribute, role, method, instance. Basically, any part of Moose is up for grabs. You can wrap methods, you can add attributes, you can add validation, you can talk to a server, whatever you need to do. And you can mix and match all of these extension mechanisms into one single package that you use. And that's what a lot of MooseX modules do. So I think MooseX Singleton does like a subclass of class, an attribute to kind of make everything work. So don't be limited by Moose's default implementation. The default implementation is nice, but that's just the default, right? You can extend it however you like. I want you to explore this region, make it, I don't know, give it wings, push its edges outward. And that's all I have. So thank you very much for your attention. So I have a few minutes for questions. Yes.
So with all respect, I'm not sure I like your approach here.
Okay.
I'm using meta programming for actual business logic, right? Well, not business logic, but for real programming. Versus.
I'm sorry. What do you mean made up programming versus real programming?
So you're using. So, in my opinion, I would think that you could do the same thing, maybe just as cleanly, if you just had a class called a form field.
Mm-hmm.
An email version of that contains the same amount of information, maybe just as succinct. But it strikes me. I mean, it strikes me a little bit odd, I guess I would say, that you're using the meta techniques of object system to do something with HTML form, the separation of concerns issue.
Okay.
Just rub me a little bit the wrong way.
Sure. More than one way to do it.
Versus this MooseX constructor extension where you're actually extending the object system. You're not talking about HTML.
Right. And I mean, the whole point of this talk is you can use the meta object protocol for things that aren't object-oriented programming related, right? So I guess,
Well, it certainly works.
yeah, it works, and I think it's cool.
And you would only use that extension, say, in the class that represented a form. You wouldn't use it in all your classes.
Right, and that's also part of the modularity that Moose could do, which is nice.
It's kind of creating like little DSL-ish, I hesitate to say DSL, but it's sort of towards that domain, that idea, and you can apply it in just the classes where you need it. It doesn't have to be every Moose using class of your object.
But if the alternate approach I was getting at, you think there would be a clear win either way? I guess I'm not. I would tend to go the other way just because.
I think it depends.
Right.
This is a really good technique to know about.
Yeah.
Yeah, and that's the whole point of this talk, is just to inform you that this exists. Yes?
I just want to be completely clear. This is a model of a form representation.
Yeah,
This is not a model of an email representation in some other thing.
right.
Okay. So this is not like for the database. So
This is for building a HTML form.
this is a technique for a form generator.
Yes.
Not a technique for an email handler.
I mean, this is for forms, but that's just one example of how you might do this. You could also do something with databases where you kind of give it a, I don't know, MySQL type or something. Or, email handling. I mean, it's all code, right? You could do anything you like. Okay. Yes.
Back to your first slide, it was like the three kind of four things of what will be. Have you ever come across an OOP length where polymorphism doesn't exist? The ability to dispatch methods against or doc typing equivalent of it, right? Interface polymorphism.
I'm going to open that up to the entire audience.
I kind of consider that a core.
So is there a programming language that doesn't do polymorphism with OOP?
Interface polymorphism in that different classes can be pointing to whatever they.
I'm sure there is.
It's hard to imagine, actually.
Right, I mean, would we add that to the list, I guess, or?
I'm sure there's an example where it doesn't exist.
It would be the number one thing.
It's the purpose of using OO. So.
Okay, thank you.